Today we are going to integrate x squared e raised to the x dx using integration by parts. However, we are going to set it out in the form of a table. Over the left hand side we are going to let u equal to x squared, and over the right hand side dv by dx is equal to e raised to the x. We are going to choose u so that when we differentiate u repeatedly, the function disappears. So the first differential of u is 2x, the second differential of u is 2, and third is 0. Over the right hand side we are going to integrate dv by dx where we stop to differentiate x squared. So this becomes e raised to the x, e raised to the x, e raised to the x. That's integrating 3 times. Right? I'm going to draw a diagonal, a next diagonal, and I'm going to draw a horizontal line. Here, the product of these two numbers is 0. So I am not going to worry about that section. I am going to invoke a sign which is plus, minus, plus. So the first diagonal, x squared times e raised to the x. I'm going to write it here. X squared times e raised to the x. The second diagonal, which is 2x times e raised to the x, 2x times e raised to the x, and the horizontal line, which is 2 times e raised to the x, 2 times e raised to the x. Right, so we have our signs. So the integral of x squared e raised to the x dx is equal to x squared e raised to the x minus 2x e raised to the x plus 2 e raised to the x plus c. And that's all. That's our integration of x squared e raised to the x dx. To verify this, I'm going to do the long method. Now recall that the integral of u dv by dx is equal to uv minus the integral of v du by dx. I am going to let u be equal to x squared dv by dx is equal to e raised to the x. So du by dx is equal to 2x and v is equal to e raised to the x. So the integral of x squared e raised to the x dx is equal to u times v, which is equal to x squared e raised to the x minus the integral of v e raised to the x times du by dx, which is 2x dx. I have to integrate this to find the integral of this. So the integral of e raised to the x 2x dx, and I'm going to let u equal to 2x and dv by dx is equal to e raised to the x. So du by dx is equal to 2 and v is equal to e raised to the x. So the integral of e raised to the x 2x is equal to u times v, which is 2x e raised to the x minus the integral of v e raised to the x times du by dx, this is a u, to, I can easily integrate this. So the integral of e raised to the x 2x is equal to 2x e raised to the x minus 2 e raised to the x. Now I have the integral of e raised to the x 2x dx. So I am going to substitute it in our original equation. So going back to here, the integral of x squared e raised to the x dx is equal to x squared e raised to the x minus, this here is linked to here, so it's 2x e raised to the x minus 2 e raised to the x, and of course plus my c. If I simplify, expand out, this becomes x squared e raised to the x minus 2x e raised to the x plus 2 e raised to the x plus c. So if I look carefully at this, we can see that it's the same solution we have up here. So the table method actually works. I will look at some more examples and show you how we can maximize our time using the table method. Thank you for watching. See you in the next video.